Whenever you're ready, man.
Okay. Hi there. Thank you for joining us. We'll give a minute or two for some people to keep hopping on. But our webinar today is how to spend less time fixing CVEs. And to begin, I want to introduce our Senior Solution Engineer, Bill Manning, who's going to help us with running this webinar and teaching you how to spend less time. Bill, you want to take it over?
Hey guys, how you doing? So today we're going to be talking about all the various things you can do to basically remediate faster. One of the major drives we have here is basically how do you do things to make it more efficient, right? I mean, that's what we do as a platform. We are the software supply chain platform. And so today we are going to talk about how to spend less time fixing CVEs. As stated, I'm Bill Manning, or it says William here. Because I go by both. I don't, how it works anyway. But I am one of the solution engineering managers for the Americas here. The thing is that when we start talking about CVEs, we need to have some context behind it, right? We all kind of know, what it means. But, the big thing is we see headlines all the time, right? We're inundated with all these headlines, and when we say software supply chain, we mean those third-party transitive dependencies. And now the thing is, it's not just the direct dependencies, right? We all know the implicit, the direct, the ones that we request as part of what we do. We're doing NPM, we're doing Python. If you're not familiar with JFrog, and what we do, definitely there's other things on that. I'm assuming that you have some context behind who we are. But the thing is that, we see these all the time. Right. And software supply chain is one of the biggest threats to most corporations in America today. And the thing is that the reason why is that most of the time people don't even realize it, but 40% of the 0 days, think about this. If you're not familiar with 0 day either, the idea of a 0 day is that when any time that there's a CVE that is created, right, they're not just thrown out there, right? There is a time period involved as part of this where, an issue is discovered, it's tested, it's over tested, it's then peer reviewed, it's agreed upon, and then the CVE is created. Well, 40% of the 0 days exploits of all time increased for 2021. And it's constantly increasing. The threat is real. When we go through this, you understand that corporations spend so much money all the time on remediating this. And the reason why the remediation takes time is because of time, right? The more time that you spend working on discovering, or if you find a CVE and discovering, what other, where is it affecting, how many projects it's affecting, takes longer, right? You got to go through. There's a lot of diligence involved, and there's a lot of discovery, and you have to go digging through and read the CVE and understand the CVE. But the thing is that a lot of these take longer and longer to identify, which means that you're more susceptible to whatever sort of nefarious or malicious cause these libraries might have to inflict. I mean, the thing is developers are artists, right? I always say this all the time. And the thing is, the medium they use is the coding language they've chosen and the libraries they use to do their job more effectively. Now, at the same time, you want your developers to be able to, go forward and innovate and create KPIs. And the faster releases that get out there, allows you to have, fixes and more features and enticements for your customer. But the thing is that these attacks, when they go on, can damage your company, not just financially, but, your reputation, which thus in turn will affect your company financially and things like that. And the thing is that the actual amount of time for an exploit decreased from 42 days to 12 days. And think about that. This is kind of a little insane. When you think about, the thing is, it's gotten faster and faster over time. It seems like we're constantly being inundated. That's the reason why I chose in the beginning, Maurice, the fire, as he's trying to work. This is what we're doing, because the thing is that all these threats are real. And most of the time, most corporations, it takes, so mean time to remediation is one of the statistics that's used in the industry when determining whether or not, a security issue is discovered, and by the time it's either, it's remediated, 58 days. That's an eternity. Think about this, right? You're always constantly working on busy cycles. You suddenly get a notification from your security team, and that takes time. And the older processes of we're an air-gapped environment because we don't want to let this in, that's even kind of antiquated at the same time too, right? You're actually hindering the velocity of an organization to develop what they do. And the thing is, these larger threats that go on all the time, it can be insurmountable for most organizations. It really can. It can be completely insurmountable. The idea of, Do we take our developers off to work on the security issues, but at the same time, we're detracting for our ability, our KPIs, are going to be reduced, the releases are going to be delayed and things like that. But what if you can do it in such a way that you suddenly have the tool sets that are available to help you not only tell you immediately that there's a CVE with what you're doing, but also provide you where it is, how it's affecting you, or even better, if you have all these CVEs, are you truly being affected by it? Listen, 21,000 CVEs were registered in 2022. Think about that. I mean, seriously, just so you know, JFrog, we are a CNA, right? We are a CVE number authority. We have a massive research team. And by the way, one of the things that I will share with you guys is that, if you guys want, we actually do have a research page that's available with all the information on how, what we're doing and things that we found, and, lots of great blog articles on how to protect yourself. But the thing is that, these number of CVEs we have is because 85 to 90% of your software that you build is someone else's, right? Your code is only around, anywhere from 15 to 10, 10 to 15%, right? The rest is all these things that you have out in the world. And the thing is that you still want to be able to provide the ability for your developers to develop, but not squish their ability to innovate. And at the same time, add a layer of protection in there, everything from shift left, which we'll discuss, right, at the developer level, where the ROI is greatest on any security tool. Listen, if you're discovering CVEs from your security team, all the way at the production level, it's 100 times more expensive for your company to remediate that. So giving all the proper tool sets, the ability to remediate faster, automation behind it, these are the things that we're going to talk about, because think about this. Every time you do a pip install, a go get Maven fetch, or something like that, it's the equivalent of plugging a thumb drive you found on the street and plugging it into your production server. Seriously, you do not know how this happens. And remember, most of these CVE attacks don't happen at the implicit level, the one that you're doing, right? These all happen behind the scenes, usually at the third or fourth transitive dependency level. I mean, look at things like SolarWinds, right? Perfect example. That was like a fourth level transitive dependency attack, and we'll talk about why. And the thing is that when you go into typical developments, you guys know this, right? You're a developer, you're given a KPI to build a piece of a to build a product or something, and you go, okay, assess it, what technology works best. Maybe NPM is the language that you've chosen to build this. Maybe it's a web-facing example, and here's giving you a quick scary thought here is that, you go through and you design this and you put your package.json together, where your dependencies, I found a library to parse a string that pulls back a hash value that I need to go do. All the things you do, you pick those libraries that best are applicable to the issues you're trying, that you're trying to build in your product. And you put it into your package.json. And I always jokingly call NPM the house party, right? You put 3 things in your package.json and 500 show up, right? Unexpectedly. Well, that's really what we're trying to make sure. Those 500 plus things that are coming in unexpectedly, how do you know? How do you security vent them? How do you make sure that you're not introducing something that's going to, go ahead and open your firewalls or release your customer data or, all these kind of components? Because when you do this, you do an NPM install, it goes and gets your third-party transitive dependencies, it brings them in, and you're all happy. I'm going to show you today how you can do things such as, first of all, you should know you can go ahead and pre-vet any of the libraries that are coming in before they even get into developers' hands, right? This is basically your preemptively stopping before it starts. But what about things that are in process? What about the 0 day? And we'll talk about too is the fact that one key factor to keep in mind if you are, a JFrog Artifactory with X-Ray kind of customer, the thing is that our key differentiator than, compared to any other product in the market is we're continuous, right? We store the binaries as a as a checksum, right? It's SHA 256. It has context behind it, what what that actual software package means. On the other side, we have this massive repository of CVE data that we've accumulated between our security team, our partnership with risk-based security, the largest proprietor of vulnerability data, NIST sources, MVD sources, and you have both of these things, right? A metadata list of binaries and a metadata list of potential CVEs. Thus, the reason why our X-Ray product is super efficient, because it's only a sheer metadata to metadata comparison. So what are you supposed to do with supply chain attacks, Bill? First of all, you need to understand the sheer magnitude of this, right? And the idea here is simple. Is that 99% of the code bases that that are out there that have been scanned by not just us, but other, organizations, analysts and stuff, 75% of those contain at least one vulnerability. That's actually kind of low, because actually we've seen larger numbers here, because the thing is that the sheer volume of this has increased, right? These potential threats and attacks have increased. 49% of the code bases had at least one high risk vulnerability. That means high or critical, right? When we're getting into the category of these could be, major catastrophic things. And the other part of this, though, and this is something people really most of the time don't think about, but most of those libraries that you're using out, those third-party transit dependencies, both the implicit, the direct and the indirect transit dependencies, are old, outdated, they've been abandoned. So we even at JFrog have this concept called operational risk. So we could even defend your corporation by looking at those third-party transitives that you're using and say, is it end of life? How old is the version you're using? Is there new versions available? And also, too, what's the health of the open source project? Are these, is this still, a viable actual entity? This is a real credible threat, because if there's an issue and it's never going to be fixed, you should know, right? So let's go back, right? And when we talk about this, the thing is that why do attacks happen? Why do you need to be noticeable, know this? Well, first of all, it's low effort. It doesn't take a lot of skill and strategy to do this. It really doesn't. Let's be honest. And the other thing, too, is that it also spreads very rapidly. Now, when I say it spreads very rapidly, think about this. The open source community is very, when I say open source, I mean FOSS, right? Free and open source software. Those third-party transit dependencies you rely on, NuGet packages, Python, NPM, Docker base level images, Terraform template, you name it, right? These are the things, but the thing is they're accepting. And when you make addition, and if you actually are a hacker of some sort, I say hacker loosely, in this case, I have my feelings on all that, but the idea is that, introducing a small library that could be potentially threatening into the supply, the supply chain of building that third-party indirect transit dependency that comes along for the ride is very fast. It's very simple. And if you associate it to a more highly used one, it doesn't take a lot of time for somebody to go and say, what are the most downloaded libraries out there, right? Because remember, it's dependencies have dependencies have dependencies have dependencies. The thing is that once it's in that stream, it just kind of gets swept up with it. You do an NPM install or a pip install or NuGet or anything like that, you're suddenly bringing this into your organization. It's like unwelcome guests. You're bringing them in. And the problem is that this can abuse a trust relationship, not only with your customers, if the vulnerability is found and exploit has been exploited, but also to inside your company. We've seen a lot of companies that when we talk to them, before they see what we can do as a platform, have this knee-jerk reaction to say, you know what, we can't control this. This is just uncontrollable. We're just going to lock out the outside world and we're going to go air-gapped. And in my opinion, all you're doing is slowing down your development and those processes, and your competitors are going to take advantage of this. And the thing is that when they do this, there's a lot of times there's don't get me wrong, I'm not even getting into the whole philosophical debate on paid exploits versus just, wanting to get the kudos down to those anonymous ones that get out there. But they're usually just some sort of malicious code or some sort of backdoor. I mean, look at, and it really depends on how it's being exploited. So saying that, though, keep in mind, in 2021, there was a 650% increase in supply chain attacks. Like I said, the flood is happening. This happens all the time. And there was an increase in 2022. It just kept going up. It just seems like, you're constantly having to worry about this. This is now a credible threat with the software industry. And we're there to help you. And the platform, we call ourselves now the software supply chain platform. I like to say, actually, we're the secure software supply chain platform, because we give you the ability to not only pre-vet binaries before they get in their hands. We also have tools like our IDE plugins. We have our CLI tool. Inside of X-Ray, there's ways to do this even more rapidly. And now we have our advanced security features that do things such as narrowing, are you being affected by this? And we'll talk about that. So when we look at what we offer as a platform, it's very straightforward. You have Artifactory, right, which is our, that's where the third-party transit dependencies that your developers are working on, both direct and indirect, are being cached. So if you have 1,000 developers and developer 0 brings down a library and all its transitive friends, all 999 other developers will use it too. You can do also 2 global sites and be able to replicate between them, so you provide consistency, non-dependent on where your developers are located. But it's also a place to store your builds, right? If you're not storing the build data in Artifactory, you should really take a look at some of our talks on builds, right? It allows accountability, because the thing is don't get me wrong, there are products out there that can find CVEs, fine, but how many are going to actually tell you how you're being affected, where you're being affected, are there any other projects being affected? And the thing is the way this happens is through our build information when you publish a build, because it allows us to actually create dependency graphs on where things are dependent on other things, and not just the project you're using, but other projects that might use that same actual library too. So you can get a blast radius if you do get hit with some sort of critical CVE. X-ray, like I said, is continuous, and you can integrate it at any point. If you look here, if we went from left to right, on the left-hand side for shift left, like I said, we have the ID plugin. I'm going to show you the CLI tool. I'm even going to show you how you can pre-evaluate those binaries before they even get into the developer's hands, right? Why let them in if you can suddenly say at the gates, hey, by the way, if you bring this in, you're bringing in a potentially critical issue that could hurt us. And we extend our security offering, by the way, and we're not going to go through it today, but if you're interested, we have plenty more talks on the consumption side. Our distribution side, we actually have the ability to, scan these things called release bundles, which allow you to actually publish out things like Helm charts and Docker images together as an immutable release called a release bundle. It's digitally signed for security. You can scan it one last time before it gets into your production. We have JFrog Connect. It's our IoT platform, and allows you to do device management, diagnostics. We even have security around like the firewalling for alerts, also the ability to roll back and deploy automatically. Lots of cool stuff. And then, of course, we have our pipelines product. And with our pipelines product too, one of the great features here is that it can be your CI. So you can use it as a straight CI. You can use it as a CD to distribute your software where it needs to go. Or if you're using more than one CI environment, you could use it as a way to orchestrate them. But really what it comes down to is what you're looking at here is a platform engineering play, right? We actually have the full gamut of everything that you need as a development organization. I mean, there's a reason why over 7,000 customers have come to trust us with the things that we do. And when we talk about automating security, and when we're going to go through today, you got to remember, it's got to be able to scan software. Let's face it, right? From package types for third-party transit dependencies to base-level Docker images and containers, right? Being able to support a majority of those things to make sure that those components that make up 85 to 90% of your software are safe and secure. Right? Getting full visibility. So we offer things like software bill of materials. Everybody's heard about this. I have a whole talk that's basically about demystifying what software bill of materials is. Basically, it's just a list of ingredients that makes up your software. We have amazing vulnerability data from our security team. You can do malicious package detection. You're going to be able to, we have 0 day. So since we're continuous security, if a new CVE comes out, you can be notified right away so you can address it and take care of it. The thing is that with the thing I'm going to show you today is fix what matters, matters fast, right? So we have this thing called contextual analysis, and we can also do contextual prioritization. I'm going to show you how you can use that information to quickly bang out through that, right? Then the other part of this that we have is also to being able to take all this information and deploy it across, your entire org, from your developers to your CI to your CD. And in the future, we'll have announcements down the road, even down to your runtime in Kubernetes. It can integrate everywhere, so you can use our JFrog CLI, our API. We have plugins for all the various CI/CD tooling, the IDEs. Like I said, we'll discuss those. And then lastly, you can use these same things I'm teaching you with our platform, whether you're using our managed solution, which which is our SaaS. I guess I like to say it's managed because it's much more than that, because you choose your own cloud provider, your own region, and all that. It could be in your own DC. It could be a combination. It could be across different cloud providers. We don't care. We bring that same level of excellence no matter how you're using us. And the thing is that some of the things we'll talk about today is our advanced features, which we just introduced late last year, which is like if you're using Terraform, infrastructure as code analysis, right? So being able to go in and determine, are you truly locking down everything when you're doing, say, something with Terraform? Secret detection. Oh my God, you would not believe inside of Docker images, how many Docker images I've scanned and found private API keys. I found, just lots of secret information. And by the way, it's usually not highly visible. Most of the time, it actually shows up in like the root history. Think about that. Somebody forgot to go ahead and actually remove the credentials. They removed it everywhere else. They just never cleared their history. Malicious code detection. We're actually going to go through and I'm going to show you some actual ways that we detect that. We also can tell you, do you have any services or applications exposed in Docker images? Perfect example, you might have a service in the background that's looking for some remote connection that you downloaded some base image off the internet. And now you suddenly have something that's, like I had one I downloaded. I started the image. I did a quick search on something. It was a popular download. I put a sniffer on it. I started the Docker image. And as soon as it started, we detected that there was a service running in the background. When I went to monitor that service, it actually was sending a request somewhere externally. And when it sent it externally, the request came back and says, hey, thanks for connecting. Give me your log files. Think about that. You're deploying a service. Suddenly you have a container start and it rings off somewhere, grabs all the log files, all the data, and deploys them somewhere else. That's terrifying, right? You have no control over that. We can help you find that. So since this is a webinar, basically a discussion about how to, I just wanted to kind of give a background, and now let's go ahead and take a look, right? So let's start off with the preventative portion first. So the first thing you want to do as an organization, always make sure that when you're designing your repositories and you look at any repository, specifically not only your local where you store your builds, I'm also making the assumption that you have some experience using us already, right? This is not new, but our third-party transitive dependencies are proxied through a remote repository. And then when you're doing this, and it could be anything type of repository that you're building. And when you go in, if you want our X-ray product to ensure that the things that you're doing are safe and secure, always go to the bottom and say enable indexing in X-ray. Once you've done this, this takes the metadata representation of those third-party transitive dependencies cache and makes it available to our X-ray product. Now in X-ray, the way you can also make sure that you actually have things that you want to make sure that you're ensuring that there's no vulnerabilities or things like that. We have like on-demand scanning and stuff is through watches and policies, okay? When you define your watches and policies, an important thing to remember is that when you are defining, here, let me close this. Sorry, I need to cancel that out. Let's go ahead and here, let's go look at my watches and policies. So policies are the rules you create in the evaluation and then the actions you take, right? And some of the tools that we have here are pretty substantial. So first of all, you have different types of policies you can design, right? You have security, you have licensing, and operational risk. Operational risk is the one that I told you about, where we can tell you how old is the actual binary that you're using. But let's just look at security for a second, or any of these rules, because the actions, non-dependent on security, licensing, or operational risk, the actions are the same. But you go in and you define your criteria on what you want to evaluate. It's a vulnerability. It can be a malicious package, an exposure. In this case, I'm just going to show vulnerability. And it's either low, medium, or high, or critical, right? In all severities. By the way, remember I mentioned when CVEs are created, there's a peer review and testing, right? There's all the standard stuff you would get with scientific method. Make sure you always have all severities. Maybe you don't take an action, but always have that, because info and warnings, by the way, come out before a CVE is released. Just so you're aware, just saying that's being an investigation. Or you determine, what CVEs score is applicable. Anytime you do this, all right, we have all these little features here. And if you look here, there's one that says skip CVE if it's not applicable. This is our contextual analysis, and I'm going to show you how you can actually enable that in a minute. But the big thing is, if you go down here, we have block download. Block download will answer that 0-day question, right? If a new CVE comes out to a library, let's say log4j, that you've been using forever, and a new CVE comes out that's critical, and you've defined a rule that's critical in terms of CVE evaluation, this will actually stop the consumption of that binary for download, right? So this is a way to prevent it from that moment. right? Because we're constantly scanning. But what about, I mentioned the fact that if you want to go ahead and have those third-party transitive dependencies, new ones that are being brought in, and you want your developers to be able to do it, but you also want to ensure that they're not bringing in something malicious, you say block unscanned artifacts. And what that does is block unscanned artifacts allows you to go ahead and say, request the binary, right? So they go, like say the package, say they do an npm install blah. It goes out and gets blah and all its indirect transitive friends, probably 300, 500, 7,000 other additional libraries that come in. It gets stored in Artifactory as cache. It gets evaluated by X-Ray. And if it meets your criteria defined by you, it's released to the developer or tool. If not, they will receive a message that the library they requested or one of the transitive dependencies that they requested is potentially threatening. So this is one way for you to go in and make sure that before you have to even go in and try to resolve these CVEs, this is a way for you to stop it from coming in. When I was talking about contextual analysis, one of the key factors here is we have this idea, which is our advanced features, is that and you can go into your index resources, where index resources is letting X-Ray know what resources it needs to evaluate. It can be repositories. Also, too, if you have any builds that you're publishing in here, make sure that they're being covered. To go ahead and manage your builds, you just click on Manage Build, find the build you want, and then you can write rules around that. So every time a build is published into Artifactory, you can be evaluated. But back under repositories, if I look at any of these, like this Docker one, what's great is, or any of these components here, is that if I go in, you can see where I can say, okay, for this repository, I want to go in and I want to configure some of my advanced features, such as I want to make sure that I have contextual analysis, or I want to detect secrets. I want to look at applications and services. Now, these features are only applicable in this case for Docker. And I'll explain, the reason why is Docker is pretty dangerous. Plus, it also gives us the ability to go in and do full scans, but it's not the only place that it's available. But once you've actually enabled those features, let's take a look and see what kind of results you get, right? And this is where it becomes super important. Now, I'm going to show you an example of a Docker image, and we're going to start there. And then I'm going to show you some of the other tool sets that are available so you can be on top of this as fast as you can. Now, Docker is super notorious. I love Docker. I also can tell you that one of the things, if you think about this, the complexity, and that's why I started here. Think about the complexity. You have an OS, you have a runtime, you have an application that you have in here. And if you haven't watched some of our other things that we do with Docker, our Docker registry, in my opinion, is tenfold greater than anyone out there. The fact that you can identify the application layer, I give whole talks on this, but because of the amount of time that we have, I want to be able to show this. So first of all, I have a Docker build here. Now this Docker build, actually, I'm going to show you the Docker build. Let's take a step back, right? So here's the Docker build that I created right here. You can see this is actually, by the way, this is a Jenkins job. This is one of my favorite ones to show because I think it really exemplifies everything that we do. I mean, even as part of this, we have X-Ray as a way to evaluate this before. You can actually build in your X-Ray scan. So when you're building this, you can even throw in an X-Ray scan to say, hey, if you could fail the build based on this, so this way you're always on top of it, even if you're doing GitOps or an automated process. But the other thing too is that when we look at this, one of the other key factors of being able to remediate faster is that here's your typical Docker registry. If you follow our best practices, one of my favorite things I love to show people is the fact that if you follow our best practices, you can actually see what application is running in the application layer of your Docker image. And from a remediation standpoint, you can even diff that application layer at the top. But that's just kind of to give you an idea of like maybe some of the other parts of remediation with these CVEs, like maybe you want to roll back, maybe you want to see if a previous version didn't have that actual issue. But let's go back to our scan list, okay, for that same Docker image. Now, the reason why I'm going to the scan list is because I actually have a tremendous amount of information. So let's go in. So I actually know that this one, and I'm not going to go into the details on how I got, I just know this was in Docker prod local. I actually looked at the build and it told me it was stored there because I can actually see the SDLC history. There's a whole nother webinar using our promotion API and emulating your SDLC for better, basically better build management. But here it is, Docker app, which is the name of my Docker, my Docker image. It's number 151. This is the version I'm interested in. Immediately, I know that there's 358 violations, that there are some malicious packages actually in this. You can see here that actually I have 275 vulnerabilities, 275 CVEs. That I'm going to get to next. I also can show you that we actually are exposing 6 levels of exposure, right? Think about this too. That means I have 6 services somewhere in this container that could potentially hurt me. But let's go inside and let's look at this. So first of all, we have the policy violations, right? Here you go. I have some security issues. I mentioned we are a CVE, right? So if I'm looking at this one, you can see here, you can actually see that it's active, that the violation state is active. You can actually organize your binaries. There's a whole thing on that too. You can see that it's a critical issue, but you know what? Our security team actually said it was medium. You can see that it's undetermined. Now I'm going to go in and show you a better way to look at this in a minute with contextual analysis, but check this out too. If you look here, this actually is a pretty terrible CVE, right? It really doesn't tell me much. It just says SQLite has an issue. Well, since we are a CVE, a CNA, we actually provide with more remediation data. And we also tell you, some additional research data that we have there, and also some reference materials, and also to, where is this impacting you? We have our software bill of materials, right? I mentioned that, I mentioned earlier, that, if you talk about things like software bill of materials, doesn't have to be this insurmountable task. If your security team comes to you, your legal team and says, hey, we need to start, using software bill of materials for legal purposes, blah, blah, blah. If you're using us, here's just software bill of materials. You can actually go ahead, even export this information as SPDX or CycloneDX. You also have the ability to create reports. I'm just going to address this now, right? I mean, your security teams are going to ask you for reports. If you're a developer and you're watching this, this isn't going to really be your thing. But here's the thing. I usually ask people whenever I show this to them, I say, I've got 275 vulnerabilities. Now think about this. I have to, as a team, for security purposes, I need to investigate 275 vulnerabilities. What is this going to do? Well, it's going to cost me money. Don't look at these as actually just besides issues. These are costing me things. Number one, it's costing me the ability for me to develop new features and functionality because now I have to redirect my engineering team to work on this, right? You need to address these security issues. Secondly, it's going to delay the release. This could impact your revenue stream, right? Because now the thing is that potentially these issues could delay new features that are coming out that might have you excel across, compared to your actual competitors. Also, as part of this, well, you know what? How long have we been affected by this? But first of all, how do I go through and say to myself, well, where do I start? But what if I were to tell you, if you're actually uploading these into Artifactory and using our X-ray with our advanced features, I could tell you when I just do a quick sort that actually out of this 275, 70% of these actual CVEs are not applicable. Not applicable. They're bogus. You know why? So what we do is we take the context of the actual CVE, we look at what the actual issue is, we then break it down to say, what is the nefarious component? We scan the binaries, in this case, the build, right? So we scan the components and say, are you utilizing these pieces? Is it? And if you look here, it says, you know what? This CVE is not applicable. You're not employing a specific component. So you can basically say and ignore this because let's face it. The thing is, if you understand CVEs is you could have a library with 100 functions and one function is potentially threatening, maybe a critical threat. It's labeled as critical. If you're not using that function, do you need to be, aware of it? Yes. But do you need to take action on it? No. And we let you know that you're not being affected. What if you start using it though? Remember, we're continuous. We will change the actual positioning on that from applicable, not applicable in this case, to, in this case, applicable. Here it is, right? So if I go in and I clicked on the wrong place. But the thing is that we actually can go in here and show you the components and say, yeah, these are applicable. Or you know what? Here's some malicious packages. We're cutting, or I don't really have any in this case, but what if there's secrets? Well, here you go. You know what? We just found a weak password and we show you exactly where it is. This is actually once the build has been completed, right? We give you that contextual analysis ability to go in and look at the pieces that you're doing and say, you know what, actually, here we go, right? Like I said, when we're returning these values, these are not applicable. And then I have other ones in here that are applicable. And the best part is we actually show you where. Here you go. These are the 2 direct locations. I just cut down your remediation time. I told you which ones are applicable to you, so you can go in and fix them. I told you that 70% of these are bogus. So now you're down to about 30-ish, 35-ish vulnerabilities you need to look at. Well, that's great, right? Here they are. They're undetermined. We let you know. But that's just one part of this, right? Understanding that, because remember, you can go in here at any time and look at the pieces that you have here and also, determine whether or not you need to go investigate it or not. And this usually this actually takes much less time, because in some cases, like this one here, this just happens to be the actual Jetty server. Yes, there is, in this case, there is a high CVE value, a CVEs score value associated to this, but are you utilizing it? And that's for you to actually determine. In this case, this actually happens to be a dependency of Jetty. And here's those services, like I talked about. These are the things, Nginx in this case is not supporting TLS. You might want to fix that. Or in this case, there's another one I have here. This is a different one, but you get the idea, right? I can go in and see, are these things, here, but where are the other ways I can do this? Well, let's go ahead and let's go to the developer, right? So I showed you how you could quickly remediate it inside of Artifactory. Well, here's an example in my case of a package.json for an npm build that I'm doing. Well, take a look here. We actually have an ID plugin called JFrog. And if you look, you can see there's a little symbol here. And if I hover over this, you can see that we're actually exposing the CVEs directly right here. We're actually flagging the libraries where it matters most, the developer. Well, let's go in and take a look. Well, here's a CVE that I found. Well, you know what? This CVE is applicable. Look at that. As a developer, I don't have to go to the UI. I'm actually, as I am coding in this, I am coding this and using dependencies. We're letting you know where it's available. Here's the information. Where's it available? Well, right here, it's an auth.json. And you know what? Hey, this one here, I'm going to take a look. I can go ahead and click on this, and this is going to bring me directly to where the CVE in question is. Think about this. Normally, you would get from your security teams a CVE report and said, okay, investigate this. Or you get a notification. So in this case, I'm actually showing you in the file. We found in the file, we found the CVE, here it is, and we actually even highlighted the actual potential threat cause right here. Here we go. This is the CVE that's applicable. We're cutting down the amount of time it takes somebody at the developer to do this. We even offer the same sort of information if you're using our JFrog CLI. I mean, you can even audit any of the things that you're doing and get the direct information right here. We also provide that if you're downloading something like a jar. Right here, I downloaded a jar that I created, and I did a quick scan before I used it. And we give you the ability to see it there and also see. Now, this doesn't allow you to go in and see some of the context, but context will be coming. And we even extend this information even to things like the Docker desktop. We actually have an extension there. So if you actually download any of the things that you're doing, you can actually see, hey, I downloaded this. Is that, even if it's not in Artifactory, is there anything potentially threatening or nefarious there? But understanding all those key concepts when you are doing this are important. Because understanding the value that comes when you can detect early and detect often allows you to remediate faster. We literally, by using the ID plugin, the CLI, by giving you any sort of level information here about the things that you're utilizing and being able to actually go ahead and delineate through any of these actual potential issues. I mean, 275 vulnerabilities. Any development team would look at this and go, oh my God, what do we do? Right? I mean, it's going to hurt. But we actually provide you. I mean, wouldn't it be nice to be able to get that information as a developer and be able to say, yeah, you know what? That we got to fix this. And you'll hear companies talk about automatic remediation of libraries, always up to the latest. In a way, that's a bad idea, right? You're going to want to test. Here we actually tell you, here's the fixed version. So we even take some of the guesswork out of it for you. Here we go. Yeah, it's applicable. You know what? Actually, if you upgrade to version 9.0, that should fix it. And this allows you to go ahead and look at what public sources are there. We also let you know, like in this case, this was a direct transitive dependency, but I'll tell you right now, we have other ones too, that where we can go in and we can show you the different impact paths on these actual binaries, right? These CVEs. So if I grab this one here and I show you the CVE, I can show you, this is a third level transitive dependency. It also lets me know I can go ahead and fix it. But in this case, because you're not sure, you're not known. So you'd have to do a little investigation, but we provide you with enough information and reference materials for you to do this more rapidly. Like I said, if you want the maximum ROI on any product, you're always, a security product, you're always going to do it at the developer level. This is where it's most important. So you have, remember, recapping, we have our JFrog CLI, we have our IDE plugins. You can also, by the way, we have other methodologies too. I should actually touch upon quickly. We have integrations to things like Jira, so you can actually go ahead and actually get all this information as a Jira ticket that's actionable. And the best part is, by the way, if I click on this, this will actually bring me to the actual library in question, right? The package that I have here, so I know, and I can go ahead and look at its X-ray data. So here we go. These are all the vulnerabilities. I can actually select this and find out more information on what this vulnerability is, right? Directly from my Jira ticket, which I love. If you're using something like MS Teams or in Slack, if you look here, you can actually use our Slack plugin that we have here, where you can see there's a whole bunch of things you can do with X-ray and Artifactory and whatnot. But it also gives you a way to get constant alerts. Are there new threats and vulnerabilities that are happening, right? And in this case, I can go ahead and click on here and go to the actual demo instance I want, or, go look at another one. So this is direct integration right here. And as I stated, you can be using any other tool or any other CI tool. In this case, like I'm actually in this case using, I have another build that I'm doing where I'm using something like Azure DevOps, which is taking a little second to load. But we even have built-in plugins for other products like that, where I can go in and just show you that, we have Artifactory, X-ray, everything built in here to evaluate binaries at any point in time while you're doing your builds. Understanding how to, basically secure your platform and have it so giving your developers the ability to remediate faster is really the key consideration here. And JFrog really brings that to the table with contextual analysis, secret detection, being able to isolate those issues down to where you can fix them and attack them more quickly. Remember, the biggest threat with this is not actually the threat itself, but the amount of time it's going to detract, the amount of money it's going to cost your organization to fix this. Because, like I said, these will help you actually fix them more rapidly, meaning that you can innovate more and remediate less. So the faster you can remediate, the better off your organization is. Well, thank you guys so much for your time. I truly appreciate it. If you have any questions, please let me know. You can contact me at JFrog or on Twitter. I hope everybody has a wonderful day. Be safe out there. Protect your company. Protect yourselves. Cheers, everyone.